Today we're going to talk about the finance chapter. The first thing in the finance chapter is a simple one-time interest, where I equals P sub 0 times R, or A equals P sub 0 plus I, which equals P sub 0 plus P sub 0 times R, or essentially P sub 0 times 1 plus R. In this case, I is the interest, A is the end amount, which is the principal plus the interest, P sub 0 is the principal or the starting amount, and R is the interest rate. And we must put this in decimal form. So let's look at what we have here. A friend asks to borrow $300 and agrees to repay it in 30 days with 3% interest. How much interest will you earn? So interest equals principal times rate. Well, our principal is $300, and our rate is 3%, which in decimal form is 0.02. 300 times 0.02 is 6.00, $6. Next, we're going to look at simple interest over time. The formula is pretty much the same with the time element added. Interest equals P sub 0 times R times T. And again, we have all the equations for the final amount as well. And everything's the same except T is for time. One note, the units of measurement for the time should match the time period for the interest rate. So if the interest rate is in years, then the time should be in years. So example 2. Suppose your city is building a new park and issues bonds to raise the money to build it. You obtain a $1,000 bond that pays 5% interest annually that matures in 5 years. How much interest will you earn? What is the total amount you will receive back from the city? So the interest equals principal times the rate times time. In this case, interest is annually, which is a year, and time is 5 years. So interest equals principal, 1,000, times the rate, 5%, which is 0.05, times the time, which is 5. So 1,000 times 0.05 is 50. Times 5, and we get $250 is the interest. So the final amount, we can start with that first formula. Final amount equals the principal plus the interest, since we have the interest, which is 1,000 plus 250, which is $1,250. Now, let's do the second part using this formula here. Say we didn't find the interest first. Then the final amount would equal the principal times 1 plus the rate, which is 0.05. This is 1,000 times 1.05, and of course this will give us 1,250. Oh, made a small error. because we got to multiply by 5 as well, the time. Scratch that. Try this again. The final amount is equal to the principal times 1 plus RT. Principal is 1,000 plus 1. R is 0.05. T is 5. And now we have 1,000 times 1 plus 0.25, which is 1,000 times 1.25, which is 1,250. We get the same thing. A patient needs to borrow $2,200 for a surgery from the bank. She obtains a 24-month loan with an annual simple interest rate of 7.5%. Calculate the simple interest on the loan. Determine the total amount she will pay the bank at the end of the 24 months. So it wants the interest, which is the principal times the rate times time. Now, our rate, again, is annual, and we have 24 months, so that's 2 years. So our time is 2 years. Our 7.5% rate is 0.075. So our interest is 2,200 times 0.075 times 2. So we have 2,200 times 0.075, which gives me 165 times 2, which gives me $330. And $2,200 plus $330 is $2,530. That is the second part. Or, again, we can go back to that formula. The amount equals the principal times 1 plus the rate times the time. So this is 2,200 times 1 plus 0.075 times 2. And 2,200 times 1 plus, and this is 0.150. We have 2,200 times 1.150, which is $2,530. So we get the same answer. Okay, this stuff on annual percentage rate, I'm skipping. That gets a little confusing. So now we can get into what is really the real world. Compound interest. Compound interest. We have the principal after n years is equal to the principal times 1 plus the rate divided by k, which is the number of compounding periods in 1 year, to the n, which is the number of years, times k again. So let's look at an example. You know that you will need $40,000 for your child's education in 18 years. If your account earns 4% compounded quarterly, how much will you need to deposit now to reach your goal? So let's look at our list of variables here. We have our Balance after n years. We have our principal. We have our rate. We have our compounding periods, and we have our number of years. So this $40,000 is what we want to have at the end. So this is the balance in the account after n years, which is 18. Okay, we have a 4% interest rate, which converts to 0.04, and it's compounded quarterly, which is 4 times a year. So we're looking for the initial principal. So we have P sub n equals P sub 0 times 1 plus R divided by K to the NK. Well, this is 40,000 equals our principal times 1 plus our rate, which is 0.04, divided by our number of compounding periods, which is 4, to the n, which is 18 times k, which is 4. So again, we have 40,000 equals principal times 1.01, and 18 times 4 is 72. So 40,000 equals principal times and 1.01 to the 72nd power is equal to 2.0471. Now we divide both sides by 2.0471. And we get $19,539.84 equals our initial principal. Okay. It's always a good idea to list your variables and name them. That way you won't get them mixed up when you use the formula. Let's look at another one here. Calculate the interest on $650 at 8% compounded semi-annually for 3 years using the compound interest formula. So again, our compound interest formula, principal after n years is equal to the principal times 1 plus R divided by K to the NK. So I don't know what my principal after n years is. My initial principal is $650. My rate is 8%, which is 0.08 in decimal form. My compounding periods, it says compounded semi-annually, that's twice a year. And my number of years is 3. So let's plug in the values we have here. So principal after 3 years is the initial principal of 650 times 1 plus R, which is 0.08, divided by K, which is 2, to the N, which is 3, times K, which is 2. So we have 650 times 1.04 to the 6th power. 1.04 to the 6th. We get P3 equals 650 times 1.2653. So P3 equals $822.45. Now, another thing with word problems is be sure to answer the question asked. The question asks to calculate the interest. So this is the principal plus the interest. So to find the interest, we simply take the principal plus the interest, subtract the principal from it, and we get the interest is $172.45. Okay, next thing we're looking at is an annuity. Now there's two formulas associated with this. If you don't know what an annuity is, it works two ways. You can put money into an annuity account on a regular basis, typically monthly. Could be quarterly, semi-annually, yearly, or anything of the nature. And eventually, after so many years, you'll quit putting money in it and start taking money out. The first thing we're going to look at is putting money in. So we're looking at a principal balance in the account after n years is equal to D, which is our regular deposit, times 1 plus R, which is our rate, divided by K, which is again compounding periods, to the N, which is the number of years, times K, minus 1 over R divided by K. Okay, it says here if the compounding frequency, which is K, is not stated, assume they are the same number of compounds in a year as there are deposits made. So this formula is getting a little more complex than what we've been dealing with. So let's write it down here. Make sure we get all these parentheses right so we do the operations in the correct order. Okay. So I'm looking for principal after n years. D, R, K, and N. So D, which is how much will we be putting in? A traditional individual account, or individual retirement account, an IRA, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw it. If you deposit $100 each month, D is 100, into an IRA earning 6%, R is 6%, which is 0.06 in decimal, how much will you have in the account after 20 years? So N is 20 years, and since it doesn't state K, and we're putting money in monthly, K is 12. So our final amount in the account is D, which is 100, times 1 plus R, which is 0.06, divided by K, which is 12, all to the N, times K, 20 times 12, minus 1, all over R, which is 0.06 over 12. All right. So let's clean this up a little bit. We'll do a few different things at a time. This will stay the same. 1 plus, let's see, what is that? 0.06 divided by 12 is 0.005. 20 times 12 is 240 minus 1, and this is all over 0.005. Okay. So again, our principal after n years is equal to 100 times 1.005 to the 240th power minus 1, and all that's over 0.005. 1.005 to the 240th power p sub n equals 100 times 3.3102 minus 1 over 0.005. So we get Pn equals 100 times 2.3102 over 0.005. Move up here. Pn equals 231.02 over 0.005. And so we have 231.02 divided by 0.005 equals, oops, 46,204. And that is it. Okay, example 8. You want to have $200,000 when you retire in 30 years. Write down our list here. So we want to have 200. So principal after n years is 200,000, and it's after 30 years. Your retirement account earns 8%. So R is 8%, or 0.08. How much do you need to deposit each month to meet your retirement goal? So we're looking for D, and it's monthly, so 12. So going back here to our initial formula, we have P sub n equals D times 1 plus R divided by K is NK minus 1, all divided by R divided by K. So let's plug in the values we know. We have 200,000 equals D times 1 plus R, which is 0.08, over K, which is 12, to the N, 30 times K, 12, minus 1, all over 0.08 over 12. So let's do a little bit of this. This is 200,000 equals D times 1, and this is 0.006, and I'll round it to 4 decimal places, 7. And this is to the 360th power minus the 1. And this here is the 0.0067. Now, if you can get rid of fractions, I say get rid of them. So let's multiply both sides by this here. I have my 200,000 times my 0.0067. That gives me 1,340 equals D. And then I have this 1.0067 to the 360th power, which is 11.0669, rounded to 4 decimal places, minus 1. and the fraction goes away, of course. I have 1340 equals D times 10.0669. I divide both sides by the 10.0669. And I get D equals $133.11. So that's not too bad. Okay, now we're going to look at the payout formula. Payout annuity. Okay, this formula is almost the same. Here's the difference. Well, let me do this. First, in the payout formula, we have the principal at the beginning. In the pay-in formula, we have the principal at the end. The D stays the same. In the payout formula, we have 1 minus 1 plus R divided by K. Here we have 1 plus R divided by K. And the next thing was this was to the positive in K, and this is to the negative. And it was minus 1 instead of 1 minus. And this is the same. So the main differences is you have this negative here, and this here is moved from minus 1 to 1 minus. So putting money in, they're positive. Taking money out, they're negative. So let's look at what we have here. After retiring, you want to be able to take $1,000 every month for a total of 20 years from your retirement account. The account earns 6% interest. How much will you need in your account when you retire? Label this so you don't get confused. So let's write down our variables. D, R, K, N. So we want to be able to take $1,000 every month. So D is 1,000 for a total of 20 years. So N is 20. Account earns 6%. So R is 6%, which is 0.06. And we want it monthly. So K is 12 since it's not mentioned. So looking at our formula here, our principal is equal to D times 1 minus 1 plus R divided by K to the negative NK all over R divided by K. So we don't know this. We know D is 1,000 times 1 minus 1 plus 0.06 divided by 12 to the negative 20 times 12 all over 0.06 divided by 12. Now let's see. We have 1,000, 1 minus, and this is 1 plus 0.005, which is 1.005, and this is to the negative 240th power, and this is 0.005. Okay, so let's do this 1.005 to the negative 240. Now you have to be careful on this. For a negative exponent, you should have a symbol on your calculator or a button that looks like this. That is the negative button. Don't use the minus or the subtraction button. It will not work. It'll give you an error. Okay. So continuing, we have 1,000 times 1 minus, and I get 0.3021, and this is all over 0.005. 1 minus 0.3021, so I get 1,000, excuse me, times 0.6979 divided by 0.005. Multiplying this, I get 6979 divided by 0.005. P 0 equals 1,395,000. That's a lot of money. Oh, that's because there's a mistake. This should be 0.9, which will take off this 0 here. Got to be careful with the decimal points. And there we go. 139,500. Okay. Have another one. You know you will have $500,000 in your account when you retire. You want to be able to take monthly withdrawals from the account for a total of 30 years. Your retirement account earns 8% interest. How much will you be able to withdraw each month? So now we're looking for D. We have our principal, 500,000. We don't know what D is. Our rate is 0.08. And it's monthly, so K is 12 and N is equal to 30. So we have our formula. E times 1. Oops, wrong formula. 1 minus 1 plus RK to the negative NK all over R divided by K. We plug in the values that we know. 500,000. We don't know D. We have 1 minus 1 plus 0.08 divided by 12 times negative 30 times 12. And this is all over 0.08 divided by 12. 500,000 equals D times 1 minus, and this was 1, and if you remember that was 0.0067, so we'll just do that all as 1. We have 1 minus 1.0067 to the negative 360th power, all divided by 0.0067. So let's go ahead and multiply by that. You get 500,000 times 0.0067, which gives me 3,350 equal to D times 1 minus, and this 1.0067 to the negative 360 is 0.0904. And we got rid of the fraction by multiplying. So 1 minus 0.096 or 0.09 0.04 equals 0.9096. We divide by that. And we get 3,682.94. And there must be a mistake here somewhere. So let's see what we have here. 0.08 divided by 12. Okay, 1.0067 to the negative 360. Nope, that's right. $500,000 times 0.0067. That's right too. That's it. There's something wrong there. That does not appear right. But we followed the steps. Let's see. Okay, after looking at it, that's right. That's how much you can withdraw monthly. So next, we're looking at your traditional loan formula. And surprise, surprise, it is exactly the same as the payout annuity formula. Now, this formula is the loan formula. Your car payment, your mortgage payment, all those things use this formula. Everything's the same. So let's see how this works. You can afford $200 per month as a car payment. If you can get an auto loan at 3% interest for 60 months, 5 years, how expensive of a car can you afford? In other words, what amount loan can you pay off with 200 per month? In other words, what is our principal? Okay, well, D is 200. R is 3%. We're talking monthly, so K is 12. And N is 5. So you can use this to figure out how much car you can afford to get a loan for. So our principal amount is equal to D, which is 200, times 1 minus 1 plus R, which is 0.03, over K, which is 12, to the negative N, which is 5, times K, which is 12, all over R, 0.03 divided by K, 12. So 0.03 divided by 12. So we get 200 times 1 minus 1 plus 0.0025 to the negative 60th power over 0.0025. So that equals 200 times 1 minus 1.0025 to the negative 60th over 0.0025. So 1.0025 to the negative 60th. All right. Put this in here. 1 minus 0.8605 0.009. And that's all over 0.0025. 1 minus 0.8609. So I have 200 times 0.1391 divided by 0.0025. So I have 2782 over 0.0025. And that equals $11,128. Okay. Next one. You want to take out a $140,000 mortgage. The interest rate on the loan is 6%. The loan is for 30 years. How much will your monthly payment be? So our principal is 140,000. We don't know what D is. That's what we're looking for. R is 6%, which is 0.06. K again is monthly, so 12. And N is equal to 30. We're going to figure out a mortgage payment here. So using our formula, we have 140,000 equals D times 1 minus 1 plus R, 0.06, divided by K, 12 to the N, negative 30 times 12, all over 0.06 divided by 12. So our 140,000 D times 1 minus, and I have 1.005 to the negative 360 over 0.005. I go ahead and multiply both sides by the 0.005. I get $700. 700, not 7,000. Equals D times 1 minus 1.005 to the negative 360 to 0.1660. 1 minus 0.1660 equals 700 equals D times 0.834. So I divide by 0.834. And I get D equals $839.33. That's your monthly payment. Okay, the last one. If a mortgage at a 6% interest rate has payments of 1,000, D is 1,000, R is 6%, or 0.06. How much will the loan balance be in 10 years from the end of the loan? K is 12, and N is 10 years. So we're looking for the balance or the principal with 10 years left. So that principal is equal to D, which is 1,000, times 1 minus 1 plus R, 0.06 divided by K, 12. to the negative n, which is 10, times k, which is 12, all over r, which is 0.06, divided by k, which is 12. We have 1,000 times 1 minus, and this is at 1.005 again. This is to the negative 120th power, and over 0.005. So we have 1,000 times 1 minus 0.005 to the negative 120, which is 5 or 0.5496, and this is all over 0.005. 1 minus 0.5496 equal to, so we have 1,000, 0.4504 over 0.005. This is 450.4 over 0.005, and we get 90,080. So that's it for this chapter. You guys have a good day, and we'll see you next time.